In this lesson, we're going to talk about adding, subtracting, and multiplying polynomials. So if you look on number 1, this is really almost just like combining like terms, but they're going to write it as like a polynomial plus another polynomial. So if you look at the first polynomial here, there is nothing on the outside of those parentheses that needs to be distributed. We're not squaring it. So we really don't need the parentheses. So we're just going to drop those parentheses off. All right, same thing with this second set. There's nothing to distribute, so we'll just drop those parentheses off as well. And then we're going to combine like terms and put it in degree order at the same time. So if it's helpful for you to write down the degree, for instance, this is a degree of 3, 1, 2, 0, 3, 2, and 0. If it helps you to do that, then write them down. There's absolutely nothing wrong with that. So I have 6x to the third plus 2x to the third. That gives me 8x to the third. My next biggest degree is the 2, so I have a 1x squared and a negative 8x squared. That gives me negative 7x squared. After that, we have a degree of 1, but nothing else goes with that 4x, so plus 4x. And then negative 7 and positive 3 make negative 4. All right, it's the same thing here, only this time we're subtracting them. So even though the first set doesn't need anything distributed, so it doesn't really need these parentheses, the second set is going to need that. So I'm going to remove them on this first polynomial. And here I need to distribute this negative. So I have negative 2x squared y squared, negative 3xy squared, and positive 2x squared. Now, when you're finding the degree, when there's more than one variable, you just add the exponents. So since I have an x squared and a 2 and a y squared, 2 and 2 add to make 4. So this has a degree of 4. Here I have x to the first, x to the, or y to the second, so that gives me a degree of 3, 2, 4, 3, and 2. So I'm going to start with my degrees of 4. Now you need to make sure that they're like terms. You could have a degree of 4 where you had maybe like an x to the first and a y to the third, and then another one that had like an x to the third and a y to the first. Those are not like terms. So I wouldn't be able to put them together even though they had the same degree. So I do have 2 degrees of 4, and they're an x squared y squared and an x squared y squared. So I can combine those 3 and negative to make 1. So I have 1x squared y squared. Then I'm going to go ahead and do my degree of 3's. I have an x to the first, y to the second, and another x to the first, y to the second. So 2 minus 3 is negative 1, x, y to the second. And then I have 2 of these degree of 2's, and they are like terms. I have an x squared and an x squared. So 6 plus 2 gives me 8x to the second. All right, on number 3, we're going to switch to multiplying. So you'll multiply just like you always have. I'm going to distribute. So 2m times 3m squared is 6m to the third. Remember, when you're multiplying, you add those exponents together. So you have the 2 and the 1, which makes the 6m to the third. Then we have 2m times negative 4m is negative 8m to the second. And 2m times 2 is 4m. 5 times 3m squared is 15m squared. 5 times negative 4 is negative 20m. And 5 times 2 is 10. Then again, you're going to just put this in degree order. My biggest degree is 3, and I only have one of those, so 6m to the third. I have a negative 8m squared and a 15m squared. That's going to give me a positive 7m squared. Then I have 4 and negative 20m. That will give me negative 16m. And then the 10 all by itself, so plus 10. On number 4, you're multiplying 3 separate polynomials. So you're going to start with the first 2 and multiply those through together. So mn times mn. M times m is m to the second, and n times n is n to the second. mn times negative 2 is negative 2mn. 1 times mn is mn, and 1 times negative 2 is negative 2. And then I'm going to combine those like terms and put this in order. I only have 1 degree of 4, so my m squared, n squared goes together. I have a negative 2mn and a 1mn, which gives me negative 1mn, and then that minus 2. And now that I've multiplied those first two together, I'm going to take that times the mn plus 4. So m squared, n squared times mn is m to the third, n to the third. Then I have m squared, n squared times 4 is 4m squared, n squared. Negative mn times positive mn is negative m squared, n squared. And negative mn times 4 is negative 4mn. Negative 2 times mn is negative 2mn. And negative 2 times 4 is negative 8. So I have a degree of 6, 4, 4, 2, 2, and 0. So 6, I only have one of those, so m to the third, n to the third. Then you have 4m squared, n squared, and a negative 1m squared, n squared gives me 3m squared, n squared. You have a negative 4mn and a negative 2mn. That gives you negative 6mn. And then your minus 8. All right, number 5. We have 6n squared times n squared is 6n to the fourth. 6n squared times 3/5. Oh, I skipped one. 6n squared times n gives me 6n to the third. Then 6n squared times 3/5 would give me 18/5 n to the second. Then we have negative 1/2 n squared is negative 1/2 n squared. Negative 1/2 times n is negative 1/2 n. And negative 1/2 times 3/5 is negative 3/10. All right, put these in degree order. I have 1 degree of 4, so 6n to the fourth. I have a 6n to the third. Nothing goes with that either, so plus 6n to the third. I have an n squared here and another n squared here, so 18/5 minus 1/2 is positive 31/10 n to the second. And then I have a lonely 1/2 n, so minus 1/2 n, and then minus 3/10. All right, so again, I have 3, so I'm going to multiply these two together. I have mn times m squared n would be m to the third, n to the second. Mn times negative 1 is negative mn. 1 times m squared n is m squared n. And 1 times negative 1 is negative 1. Although there is no like terms in that, I'm going to go ahead and put it in order. So I have m to the third, n to the second, plus, and then my degree of 3, m squared n. Then my degree of 2, negative mn, and then my minus 1. And I'm taking that times that third one. Now, if you don't take your time on these, you're probably going to get some of these wrong, because earlier I think I even wrote down, a 2 instead of a 3. You just have to be really careful. So we have m to the third, n to the second times mn to the second would give me m to the fourth, n to the fourth. Then I have m to the third, n to the second times 2 would be 2 m to the third, n to the second. M squared n times mn squared would give me m to the third, n to the third. M squared n times 2 is a positive 2m squared n. Then I have negative mn times mn squared, so we have negative m squared n to the third. And negative mn times 2 is negative 2mn. Then we have negative 1 times mn squared is negative mn squared. And negative 1 times 2 is negative 2. So I have a degree of 8, 5, 6, 3, 5, 2, 3, 0. So I only have one degree of 8. So that's going to go first. So m to the fourth, n to the fourth. I only have one degree of 6, and if you have to cross them out, cross them out. So plus m to the third, n to the third. Then I have 2 degrees of 5, but they're not like terms because this one is m to the third, n to the second, and this is m to the second, n to the third. So I'm just going to write them down separately because they aren't like terms. I can't combine them together. And I usually go with alphabetical order, biggest degree. So since m comes before n and this has m to the third, I'm going to list this one first. So 2m to the third, n to the second, and then the negative m squared n to the third. Then I have degrees of 3, but again, they are not like terms, so I'm going to do this one first. Plus 2m squared n, and then minus m n squared. Then you have a degree of 2, so minus 2m n, and then your constant negative 2. All right, on number 7, we have more going on here. So I have this 3x that I need to distribute here and multiply throughout. I also have this negative, and then I have 2 things that need to be multiplied here. So you can do one of 2 things. You could go ahead and distribute this negative throughout here. Only do it to the first one, though, not the second. And then what you get there, you can multiply times the 5x plus 2. Or you could choose to go ahead and multiply this together and then distribute the negative. That's also something that is valid. I'm going to distribute the negative first. So take this 3x and distribute. So that gives us 6x squared. And then 3x times negative 6 is negative 18x. And then I'm going to distribute here. So I need a plus sign because this is still going to be multiplied times the binomial behind it. So this gives me 4x squared and negative 7x times 5x plus 2. So I need to go ahead and multiply this together. I'm going to leave my 6x squared minus 18x out in the front. So 4x squared times 5x is 20x to the third. 4x squared times 2 is 8x squared. Negative 7x times 5x is negative 35x squared. And negative 7x times 2 is negative 14x. Then I'm going to combine like terms. All I have is this one term that's a degree of 3. So 20x to the third will be in the front. Then I have 6x squared, 8x squared, and negative 35x squared. If you add those all together, you get negative 21x squared. And then 18x and negative 14x make negative 32x. All right, on number 8, we're just distributing. 7a times 2a squared is 14a to the third. 7a times negative 5a is negative 35a to the second. And 7a times 3 is positive 21a. 2 times 2a squared is 4a squared. 2 times negative 5a is negative 10a. And 2 times 3 is 6. So degree order, I'm going to start with that cube. So 14a to the third. I have a negative 35a squared and a positive 4a squared. That's negative 31a squared. 21a minus 10a gives me 11a. And then we have plus 6. Hachi makes Seminole Indian dolls to sell at the local street market. As Hachi produces a greater number of dolls, she can lower the cost per unit. The cost of making X dolls can be represented by this function. C of x equals 12x plus 64. The function v of x relates the price v to the number of dolls produced, which is your x. How many Seminole Indian dolls should Hachi sell each week to maximize her profit, P? Recall that profit equals revenue minus cost. All right, so I think we need to come up with a revenue equation. So revenue would be the price of my doll times how many dolls I'm going to sell. Well, I know that the price of my doll is represented by this equation. So if I take the price of my doll and I multiply that times an X number of dolls, I can get an equation for the revenue by distributing. So I'm going to distribute this. So that would give me 49X minus 2X squared. So there's my revenue. The profit, let's just call that P of X, is the revenue, so how much I'm selling the dolls for, how much I'll get when I sell a doll, minus the cost of making the doll. So I have my R of X, that's the 49X minus 2X squared. And I'm going to subtract the cost. Now, they gave me the cost up here. It's 12x plus 64, but it's coming behind a subtraction sign. So I need to put that in parentheses so that I can then distribute that negative. So I have 49x minus 2x squared minus 12x minus 64. So if I combine like terms, put this in order, I get negative 2x squared. 49 minus 12 gives me 37x minus 64. So this is the cost. This is the cost, or the profit. This is the profit I will make. If I know how many dolls I'm going to sell, I can figure out the profit that I will have, which is how much I'm actually going to make after I pay, you know, everything that it costs me to make the dolls. Now, the question is, how many Seminole Indian dolls should she sell to maximize her profit? So let's say that we graph this. Let's graph it and take a look and see what it looks like. So we have negative 2x squared plus 37x minus 64. Now I'm going to adjust my viewing window, all right, because if I go to just my normal viewing window, it's not going to look right. I'm not going to be able to see the maximum. So I'm going to adjust my window. I'm going to go with x minimum of 0 all the way up to an x value of 20, and then every tick mark is going to count by 2. For my y values, I'm going to start at 0, go to 140, and every tick mark is going to count by 10. All right, so I look here on my graph, and remember, I'm counting by 2, so this is 2, 4, 6, 8, so on and so forth. So these x values represent the number of dolls I'm going to sell. The y values represents my profit. Well, obviously, this is the most profit I can make, whatever this is up here. Well, if you take a look, the number of dolls would be the x value. Well, it's somewhere in between here and here. So if I'm looking, I've got 2, 4, 6, 8, 10. So somewhere between 8 and 10 dolls, I am going to make the most profit I can. I can't sell part of a doll, so the most realistic number to go with would be 9 dolls. Now, if I go to my table and I plug in 9, I know that if I sell 9 dolls, I am going to make $107. Now, that doesn't mean that I'm getting $107 for every doll that I sold. That means that they're going to pay for their doll. I'm going to take out all of my operating costs, or how much it costs me to make the dolls, and what's left over is $107. All right, so I know that if I sell 9 dolls in a week, notice they said each week, 9 dolls each week, so per week, I will have a profit of $107. Now, Hatchie's profit function, y equals p of x, is represented by the graph, this graph right here. Now remember, that's negative 2x squared plus 37x minus 64. We came up with that equation in the last problem. Kaio's profit from selling X flower pots can be modeled by the function that they've given you here. All right. It says find the y-intercept of each function. Who would lose more money if neither person sold any items? Well, that's what the y-intercept represents, is if I sell no flower pots, what is the cost? Well, or if I sell no dolls. Let's do Hatchie first. So if I want to find the y-intercept, I'm going to plug 0 in for x. Now, they did that right here. They showed you that this x-intercept is 0, negative 64. But you can get that by taking and plugging 0 in for x, and you get negative 64. That means I'm going to lose $64 if I don't sell any dolls. So obviously there's some kind of startup cost there to make the dolls. Okay, I've already purchased materials or something like that. All right, let's talk about Kaio. So for Kaios, I've got 0 times 0 minus 3 times 10 minus 0, which gives me 0. I just plugged 0 in to the equation that represents the profit for Kaio. So $0. When I plug in 0 for x, I get $0. So if I sell no flower pots, I lose no money. That just means he has no startup costs. Okay, he hasn't spent any money to make the money. So the person who would lose the most would be Hatchie. So Hatchie will lose $64 if they do not sell any dolls. So it says interpret the end behavior of the functions. Well, I can see that this end behavior is negative and this end behavior is positive, and that is negative. And I know that I could tell that anyways by this, because this is even, so they're either both up, both down. And I'm negative in front, which tells me I'm going to end on a negative note. This equation, if I were to multiply this out, all right, I've got x times x minus 3. That would be x squared minus 3x. And then I would have to take that times 10 minus x. So I would get 10x squared and then minus x to the third, and then minus 30x plus 3x squared. So I would end up with negative x to the third plus 13x squared minus 30x. This is odd, and we're going to end on a negative note. So it should be up over here, and then something happens in the middle, and then down on the right-hand side. If I graphed it, that's what it would look like. So at some point, the more dolls I make is actually going to make me lose money. Like anything down here means I'm losing money. So 16, if I sell 16 dolls, I'm going to break even. I'm not going to make a profit at all. Okay? But if I sell over 16 dolls, I'm going to actually lose money. All right? Same thing over here. If this goes down, at some point you're going to be in the negative profit. So that just tells me that they both have a finite number of items they should sell to maximize their profits.